Behavioral Neuroscience, Chapter 9, Segment 2, pages 271 to 280. Auditory signals run from the cochlea to the cortex. The auditory portions of the vestibulocochlear nerve is a cranial nerve that is made up of 30,000 to 50,000 auditory fibers from the cochlea on each side of the head. This portion runs from the cochlea to the brainstem auditory nucleus. Each auditory neuron in the nerve fibers is stimulated by a different auditory frequency at its threshold, but for more intense stimuli, the neuron responds to a broader range of frequency. Graphically, this is displayed and represented by the tuning curve. One neuron's information isn't enough to identify the frequency of a stimulus, but the information of multiple neurons combined, whose ranges all include the frequency of the stimulus, can help the brain identify the frequency. So think of all these tuning curves overlapping, and then wherever they all overlap, that's the spot where the brain identifies the frequency of the stimulus. Now, the cochlear nuclei are the brainstem nuclei that receive auditory input from the hair cells and send output to the superior olivary complex. One path connects them from the superior olivary nuclei and is responsible for the first stage of binaural sounds in the central nervous system. Several parallel paths converge at the inferior colliculi, which are primary auditory centers for the midbrain. Their outputs go to the medial geniculate nuclei of the thalamus. Two pathways go to several auditory cortical areas. Tonotopic organization exists in all levels of the auditory pathway, and it is the spatial arrangement according to stimulus frequency, with cells responsive to high frequencies located at a distance from those responsive to low frequencies. Primary auditory cortex is activated by many sounds, which it processes. It's located at the superior temporal cortex. Pitch information is encoded in two complementary ways. There's minimal discriminable frequency, which is the minimum difference in frequencies that can be detected reliably. There's place coding, which is the use of the most stimulated portion of the basilar membrane to identify the location of the sound. So the aspect of pitch, so you have treble, which is the aspect of pitch corresponding to high frequency sounds, and then bass, which is the aspect of pitch corresponding to low frequency sounds. So you have temporal coding, which is the use of the amount of action potentials given off by an auditory nerve to determine the frequency of a sound. Then you have infrasound, which is low frequency sound below the human threshold, and then you have ultrasound, which is high frequency sound, which is above the human threshold. So infrasound would be 20 hertz or lower, and ultrasound would be 20,000 hertz and higher. What is that flash? Why is it? Then you have the brainstem auditory systems are specialized for localizing sounds. So binaural is a term pertaining to two ears, and that's very important when discussing this topic. There are intensity differences, which it's the perceived differences in intensity between both ears, which can be used to localize a stimulus. And then you have latency differences, so it's the difference in time of arrival for the stimulus to either of the ears, which is also used to determine where a sound is coming from. So if something occurs, in front of me but a little to the right, my right ear will hear it first, more than my left ear in terms of intensity, and so that will be determined as being somewhere to the right, and also will arrive to my right ear first, and that's more information that can be processed to determine, the general area where that the source of that stimulus is coming from. And you have the duplex theory, which is the theory that our ears, which combines these two. It's the theory that our ears compare the arrival time and intensity of sounds to each one in order to determine the location of the source of the sound. Then there's a thing called the coincidence detector, which is a device that detects the co-occurrence of two events. Spectral filtering is the alteration of the amplitude or some but not all frequencies in a sound. The auditory cortex processes complex sounds. So amusia is a disorder characterized by the inability to discern tunes accurately. So people with amusia wouldn't be good for music. Diffuser tensor imaging, which is used for this, is a modified form of MRI in which the diffusion of water in a confined space is exploited to produce images of axonal fiber tracts. Hearing loss is a major disorder of the nervous system. Hearing loss, everyone knows, is a step towards deafness, where you have decreased sensitivity to sound in varying degrees, and then you have deafness, which is the complete lack of speech perception. And you have conduction deafness, which is a hearing impairment that is associated with pathology of the external ear or middle ear cavities. Then you have sensory neural deafness, which is a hearing impairment that originates from cochlear or auditory nerve lesions. Ototoxic is something that is toxic to the middle or inner ear.